Hello there, this is Xiang Li. Welcome to the demonstration of my visualization project, the visualization of the wildfires with weather data in California. In this project, we want to discover the relationship between the wildfire occurrence and the weather condition. So I merged the wildfire dataset with the NOAA weather dataset. And this demo contains three parts. The first one is the visualization of the raw data. Then comes the data analysis. After that, it's about filtering. And finally, I will show some little details. So let's get started. As you can see here, we have a map showing all the wildfire events. Let me zoom in a little bit. And the heat map here shows the frequency of the wildfire. Circles in the map shows the fire events. The color here means the size of the wildfire. By clicking the circle, it shows the detailed information of this wildfire with weather condition on that day. Now let me change the legend. Here the colors reflect the cause of the fire, and this legend works for all the dashboard. And you can also show the location of the weather station. By clicking the icons, you can see the detailed information of this weather station. Okay, now let's go back to the home. So let's move on to the next figure. In this figure, it shows the number of occurrence of the wildfire versus the date. You can see a clear pattern that the wildfire occurrence is related to the month. And to be more specific, it should be related to the weather. And that's the original intuition of this project. Move to the right, we can see that the number of occurrence and the total burned area versus different causes of the wildfires. In this figure, we can see that most of the fire events are small. However, the burnt area are mostly contributed by the large wildfires. And let me go back to this legend. And in these figures, we can see that most of the fire events are small and caused by equipment use and lightning. Now we can move to the second section, analysis. The first thing I did is multi-dimensional scale. We have two plots here showing the samples in lower dimension and the relationship between all the features. You can see that here the minimum, maximum, and mean temperature are quite close. Dew point is also close to this group. Because the California is relatively long and thin, the longitude and latitude are related. Finally, the visibility and the wind speed are related. The precipitation here is close to the fire size. If it's raining outside, the fire size won't be quite large. And here it's the interactive PCP. You can change the order of axes by dragging them. The path between the features in MDS will change accordingly. Then let's move on to the PCA. The script plots show the variance explained by each principal component. And this biplot shows the projection of samples and feature vectors in the first two principal component domain. And this table shows the significance of variables calculated by selected principal components. By clicking the bar in this figure, you can change the number of the principal components we are using to calculate the significance of the variables. And here is the selected variables. And here is the scatter plot of the samples along selected features. So this is the end of the analysis part. Now we can move to the filtering. In this project, users can apply temporal filters to focus on the time period they are interested in by clicking and dragging on this figure. You can easily select the time period, and all this visualization and analysis will change accordingly. Also, go back to the map, you can filter the desired events you want by clicking the legend. And finally, we have some dynamic layouts, so that this page can fit different screens with different sizes. And I also did some optimization, so that some details is only displayed when you zoom in. So basically that's it. Thank you for watching.